Okay, so in this video we're going to have a look at percentages using a calculator, and to understand all of this you've really got to understand the use of the multiplier. Now if we go back to what we were doing last video, we were having a look at finding 15%, and we said that 15%, oh dear, why is that not working? There we go, 15% is the same as 15 out of 100. So as a multiplier, well, 15 out of 100 as a decimal is just 0.15. So if I wanted to find 15% using a calculator, I don't need to find 10% and 5%. I can literally just find 15% of something means I can do 0.15 multiplied by whatever it is. So if that was £400, in my calculator, I can just do 0.15 multiplied by 400, and that will tell me any percentage amount. So if I wanted 23% of something, I would just need to do 0.23, because that's 23% as a decimal, multiplied by whatever I was trying to find 23% of. That seems fairly straightforward, so let's have a look at what happens when we do increase and decrease. Now, when we do increase or decrease, let's think about what we did when we were doing it without a calculator. So, we took our original amount, whatever it was, our £400 or whatever it was that we had. And if we were doing a 15% increase, we would find 15% of it. So let's call that 15%. So 15% of 400 would be 60, so that would be £60 if we were doing it without a calculator. And then if we were doing a percentage increase, I'm having a little bit of problems with my pen today, there we go. If I was doing a percentage increase, I would add them together and that would give me 460 and I would be done. Well, let's see if we can do it a bit smarter. What are we actually doing? Well, our original amount, our £400, is our whole one, the thing that we started with. So in terms of percentages, it's 100%. Now our increase that we've added on was 15%. So really, because we're going to add 100% and add on 15%, really what we're saying is we want 115% of whatever it was we started with. So in this case, it would be 400. Okay? So if I want to increase by 15%, really what I want is 115%. Well, 115% as a multiplier or as a decimal is 1.15. So that means I can just find 15% increase by plugging that into my calculator, doing 400 times 1.15. So in summary then, if I want to increase by a certain percentage, I just add on that percentage. So if I wanted to do an 80% increase, which is a heck of an increase, I would say I want my 100 and I want to add on 80%. So in total, I want 180%. So as a multiplier, that would be as a decimal 1.80. Don't really need the O. So now I can find an 80% increase just by multiplying by 1.80 in my calculator. Right, let's have a look at decrease, which is a little bit harder. Okay, so with a decrease, you've got your 100%. Let's say that represents £400. And that represents my 100%, the thing that I start with. Now if I want to decrease, I want to, in effect, chop off a bit. I don't want, let's say I want to do an increase of, a decrease of 10%. This is a sale and we want 10% off, decrease of 10%. Well, that means that's my 10% and I don't want that. I want to take that off. Well, if I take 10% off 100%, subtract 10%, well, that gives me 90%. So I'm left with 90% here. So really, if I want to do a decrease of 10%, that is the same as saying I want 90% of. So that's what's left. And how do we find 90% of? Well, we just put it into a decimal. So 90% divided by 100 is the same as timesing by 0.9 or 0.90. So if I want to find a decrease of 10%, I just need to multiply my amount by 0.9. So if I wanted to do 10% off 400, 400 multiply 0.9, if you pop that into your calculator, that will give you 360. And I haven't had to work out 10% and do any subtraction. My calculator will do it all for me. Now, the great thing about the multiplier is once you've understood the multiplier, not only can you do increases and decreases with your calculator, but you can do compound interest, real interest, the interest that goes on in your bank account. So let's say I've got £2,000, which I had, but let's imagine I've got £2,000 and I'm going to put it in a bank account that pays 3% interest per year. And I'm going to leave this in its account and just ignore it for, I don't know, the next 10 years or something. Let's have a look what happens. So after 1 year, having real problems writing with this new pen. Here we go. After 1 year, well, I'll have £2,000 plus I've got 3% increase. So that's like saying an increase of 3%. Well, we know from what we did before that that's 1.03. Okay, and I could put that into my calculator and work it out, and that's what I'd have after 1 year. Now, let's have a look what happens after 2 years. Well, after 2 years, I want to take what I've got in my account from previous years, so that's whatever that turned out to be, and then I want to increase that by 3% because I get 3% on all of that, so I'm going to times it by 1.03 again. After 3 years, well, I'll take everything that I had in my account last year, so that was that, multiplied by that's from my last year, and now this year I want to times that by 1.03 because I've got another 3% on everything that's in my account. And very quickly you will see that to find compound interest, you take the amount that you've invested, if you like, so your original amount, you times it by your multiplier, so in this case that was 1.03, to the power of n, where n is your number of years. If I just make that a little bit smaller, let's just move that up here. So this means after 1 year, I will have 2,000 times 1.03 to the power of 1. After 2 years, well, I had 2 of these 1.03, so I'll have 1.03 squared. After 3 years, I will have 3 lots of it, so that's what I need to put into my calculator. And if I left it there for the next 10 years, because I had nothing I wanted to do with my money, so I left it there for 10 years, I would have 2,000 times 1.03 to the power of 10. And I can put that into my calculator and find out how much money I will have in 10 years' time. Fantastic. Okay, the final thing that we need to be able to do is our reverse percentages. Now, these guys can be quite tricky. You have to read the question carefully. So I'm going to give you an example of a kind of question that you might be asked that tells me it's reverse percentages. So I am told that a radio has gone up by 10% and now costs £110. So let's have a look at this. So I would have taken my original amount, I would have multiplied by the multiplier, whatever that is in this case, and I would have got my final amount. Right, this time I don't know what the radio cost. Oh, that's interesting. Instead of timesing by the multiplier, I don't know what goes there. All I do know is that whatever it was increased by 10%. And we know that an increase of 10% is the same as multiplying by 1.1. And when I did that, I got an answer of £110. In the question, it's like, what was the radio before last year? Before I did this increase that I've got going on here, what was the radio costing then? So here's what we had in here. What was it before? So something multiplied by 1.1 gave me 110, but what is it now? Well, we need to go back the way. So we need to do the inverse. So we need to divide by 1.1. So with a reverse percentage, we need to do 110 divided by 1.1. And if you do that, you will get back to 100. Now, you can always check you've got it right. If I do 10% of 100, increase, add it on, well, 10% of 100 is £10, add it on, I will get 110, so I know that I've got it right. You need to watch out for reverse percentages. The clue is really in tackling the question, understanding the wording in the question. So I've got something that sounds like a train ticket costs £38.76 after a 14% increase. How much would the train ticket have cost before the price increase? So if we go back to our bubbles, we've got a bubble and another bubble, and I'm picking out the words 14% increase. Oh, well, I know how to do that. 14% means I want 114%, so 1.14 is my multiplier. And I'm told after this increase, it's cost £38.76. What was it before? So what was it before I increased it by 1.14? So I need to do 38.76 divided by 1.4, and that will tell me how to do all of my reverse percentages.